goal today, the students will understand how to factor and combine like terms. To let you guys know, we will continue with this big time next year. This is another one of those big ones that we're going to see a lot. We're going to learn how to do way more complicated factoring next year. So this is kind of like an introduction into that. Okay, so when we're looking at this, we have been working with distributive property, which is when you take this number and give it to both terms, and then you get this. That's what we just did in the warm-up. Now, the flip side of that is factoring. It's kind of like in Jeopardy. If I give you the answer, you got to rewrite it back to what the question was. So that's this right here. And so what you have to do is you have to pick out the greatest common factor like we did in the warm-up. So the greatest common factor of 10 and 45 is 5. 5 goes into both of those numbers. So you pull out a 5, and then you're saying 5 times what gets you back to 10? Well, that is 2x. And 5 times what gets you to 45? That is 9. So it's rewriting it back in this, and this is called factored form. Okay? All right, so let's try some of this and see if it starts to kind of make sense. All right, so it's going to start you off very, very simple. So it's going to actually give you the greatest common factor between 8 and 4. And the greatest common factor is 4. And they wrote it right here. So 4 times what will get you back to 8a? 2a. So I'm going to write 2a. And 4 times what will get you to 4? 1. So the factored form is 4 times the quantity 2a plus 1. Okay, so let's look at the next one. What is the greatest common factor between 14 and 21? Stephen? 7. So I'm going to pull out a 7. I'm going to put it out here. That's my greatest common factor. 7 times what will get me to 14x? 2x. And then 7 times what will get me to 21? 3. So my factored form is 7 times the quantity 2y plus 3. You do not need another set of parentheses out front. Typically, you're not going to see those. You're going to see this. That's how it's usually written. Okay? All right, you can do this with 3 numbers. You can do it with as many numbers as we want. But you have to find the greatest common factor for all 3. So what's the greatest common factor of 12, 16, and 10? 2? Okay. So we're going to pull out a 2. And then we're going to say 2 times what gets us to 12a? 6a, right? And 2 times what gets us to 16b? 8b. It does have to be the greatest common factor, yes. 2 times what gets you to 10? 5c. Okay, questions on that before we move on? All right. All right, go ahead and see if you can write the factored form of that one on your own. All right, what is the greatest common factor of 12, 42, and 3, Hassan? 3. So I'm going to pull out a 3. And then 3 times what will get me to 12x? 4x. I'm going to keep the subtraction sign. 3 times blank gets me to 42y? 14y. Keep the subtraction sign. And then 3 times what gets me 3? 1. So there would be my factored form. Okay, questions on that before we keep going? No? Okay. All right, so next thing we're going to talk about is like terms, which we talked a little bit about last chapter. I do have a little silly video, and it's pretty silly. Okay, so the idea of like terms, I know that was a pretty silly video, but the idea of like terms is that they have to be exactly the same in order for you to put them together, which is kind of what we had started in that last chapter, and I was like, you just put them together. And so look at these, the difference between things that are alike and things that are not alike. So this first column, these both have x's in them, so you can combine them and put them together. If they both have x squareds in them, you can put them together. If they both have xy, you can put them together. And if you have plain numbers, obviously you can put them together. Catherine?
What if you like ran out of variables?
What do you mean ran out of variables?
Like if you have like 26 different things.
You're not going to see that. Yeah, you can go into the capitals also, so that gives you another, so 52 of them. Yeah. All right, now things that are not alike, like in the video, you can't have a 2x and put it with a 2y. Those two are not going to combine. They cannot make little digits. Okay? And then you can't take an x squared and put it with a plain x. I know, it's kind of funny. Little digits. I know. Did you notice that every baby had an 11y on it?
Yeah.
Yeah.
No.
What? Poor Samantha.
7 plus 4
Oh my.
equals
Oh my. All right. Then this one has an XY. This one just has an X. So again, can't put them together. They have to be exactly the same. This is a plain number. This is a number with a variable. Can't put those together. They literally have to be exactly the same. Okay? All right. So let's look at the next slide. All right. Determine which 3 expressions have like terms. It says drag them. If you guys just want to circle them, that would be great. So look through there and decide which ones have the same terms. All right, so let's look through these. Okay, so first one that has like terms is this one right here. So n plus 6.25 n. If I would add those two together, there would be an imaginary 1 that sits here, and I would just add it together, and I would get 7.25 n. All right, the next one that has like terms is the A's. They both have an A behind them, and I could just add those together. So negative 5 plus 8 is a positive 3A. And then the last one that has like terms is this one right here. And this is 7 minus 10, or 7 plus a negative 10, which would give me a negative 3xy is how I would combine those together. Okay? Does that make sense okay? All right. And we're going to do tons with that, like I said, next year. Lots and lots and lots. Okay, so you can see directions say 2 things. Sometimes in the stuff that we're going to do this year, next year, it's going to just say simplify. And simplify means that one should make it simpler. Or sometimes they'll say combine like terms, and that both means the same thing. So now we're going to go through and combine these. You have to look to make sure they're exactly the same. These two are the same. So this is a negative 6k and a 7k, so that's going to give me k. You can put 1k, but you're not going to see that. I don't think digits is going to take it either. But if on a test you would put in 1k and it tells you it's wrong, I'll give that to you because mathematically that's the same thing. So you just want to put a k. All right, what do you think about the next one? Yeah, because this is negative 4. If I change my signs here, negative 4 plus a negative 10 would be a negative 14x. Okay? Now, the last one, you can't combine all 4 of those. Why can you not combine all 4 of those together? They don't all have variables with them. Okay, so I can put the numbers together and I can put the variables together. We typically will start with writing the variables first. So this is a 1n because there's nothing else with it, so we know there's one of them there. This is actually a negative 5. So what's 1 plus negative 5? Negative 4, and then we put the n. Okay, so then we can put the numbers together. So this is a 4 and a negative 9. 4 plus negative 9 would give us a negative 5. So I can either write minus 5 or I can write plus negative 5. And I need to know that either one of those answers are the same thing. Again, if digits would count that wrong and you put it like this, you can come show me to get that right because that's mathematically the same thing. What's wrong? Oh, you got it wrong. Oh, no. All right. Okay, last slide, what I want you guys to do is, I was going to do whiteboard practice, but I think, based on time, I think since we had that fire drill, go ahead and work this whole slide, and then we'll go through and check it and make sure you understand everything I just went over. All right, what's the greatest common factor on number 2? Listen. 8. So this would be 8, and this would be y minus 9, because 8 times 9 is 72. Okay, number 3, what's the greatest common factor on number 3? Samantha? 9. So I pull out a 9, and then what's left is a plus 2. What is the greatest common factor on number 4, Dylan? 3. 3, so I pull out a 3, and this is b minus 9. Any questions on factoring? All right, moving on then, combining like terms. Number 5, what does negative r take away 10r? Nora? Good, negative 11r. Okay, because there's an imaginary 1 that sits there. This would be plus a negative, so negative 1 and negative 10. All right, number 6. What can I combine there, Katie?
The x's.
Good.
So it would be 4x.
Plus 11. Good. Okay, all right, and then number 7, 11r take away 12r. Catherine?
Negative 1.
Okay, digits is probably going to want it to look like that. I don't know that 100% for sure, but careful with adding in that 1. I'm not sure they're going to take it. All right, and number 8, Carter.
11B.
Yes, 11V, because this is a -1. -1 plus 12 will make it a positive 11. Okay, any questions on any of that I need to help you with? Good. All right, if you need to show me any work today or anything,